Thermals cause a lot of problems in die casting, a lot of problems. More and more we're seeing that the thermal design of the die is somewhere around 80% of the problems that we're seeing. And it can be anything from a little mama and papa shop out the back with 2 die casting machines to some of the big guys. Some of my customers have got 750 die casting machines. One of them's got over 1,000. But it's a consistent problem. Thermal problems. Shrinkage, porosity, and thick sections. You can't always stop the shrinkage porosity, but in most cases you can. So if you know you've got a thick section, you can do a quick review of thickness using CAD or using some of the other simple simulation packages for thermals. And you can see that there are thick sections and you've got to cool them. So you put the appropriate cooling in, that's it. As long as that casting section freezes before the surrounds, then there will be no shrinkage. Shrinkage porosity occurs because aluminum, zinc, magnesium, brass all shrink as they freeze. Cold flow in thin areas. We know it's a thin area. We can work out how much heat we need in that die, and we can add water cooling or not, or thermal, or change the design of the die so that it's a more thermally isolated, not insulated. We can do that to make a die hotter by the very design of the die. We're going to go through that in later webinars. So in some cases we put water cooling, in other cases we put oil heating, and in other cases we thermally isolate each section of the die so it becomes quickly to heat up and quickly to cool down. It's called a ballerina die. Cracking and sinks in hot areas. Cracking is mostly a thermal problem. If one section is cooling faster than another, it wants to shrink. It will apply stress on other areas. If they are hot, then those areas will crack, because all molten metals, as they just freeze, they have very little strength. I can take a screwdriver and push it through a casting just as it's frozen. So if it's sitting just below the solid temperature, I can push a screwdriver through the casting. It's very weak. Sinks in hot areas are just shrinks just near the surface. Often in one die, you can get a casting that's cracking in one spot and sinking in another, which makes it difficult. But it's very, very common, unfortunately. So the cracking says, I'm shrinking in the die, get me out sooner, eject after 3 seconds cooling in the die, or you get hot cracking. The sink is saying, leave me in the die for 4 seconds, otherwise you're going to get a sink on the surface. So you have this compromise. 3 seconds, over 3 seconds you get cracking, under 4 seconds you get sinks. So you eject to 3.5 seconds and some are cracked and some have sinks, and you say, gee, this is a difficult part. If you'd have done the thermal design from the beginning, then it wouldn't have been.
To purchase access to this course, visit the NADCA Marketplace at www.diecasting.org/store. Purchasing a course through the online education system grants you 1 year of access to the recording, presentation, support material, and test when applicable. NADCA video news and information is brought to you by the following sponsors.